Hash the planet where it rains diamonds. Picture this. You're standing outside during a storm, and instead of raindrops hitting your face, it's diamonds. Not little sparkly bits either. We're talking chunks of pure crystallized carbon falling from the sky like hail. Sounds like something out of a fantasy movie, right? Well, it's not fiction. This is happening right now somewhere in our own solar system. Two planets, actually, are out there in the freezing dark, raining diamonds constantly non-stop for probably billions of years. So let's talk about it. Let's talk about Neptune and Uranus, the two ice giants sitting way out on the edge of our solar system, and why scientists think these worlds are absolutely drowning in diamond rain. First things first, let's set the scene. Neptune is the 8th planet from the Sun, the furthest one out there. It's cold, it's dark, it's windy as hell, and it's basically a giant ball of ice and gas floating billions of miles away from us. Uranus is right next door, sort of, the 7th planet, and it's just as weird and just as extreme. These two are called ice giants, and that name is kind of misleading if you think about it too literally. It's not ice like the ice cubes in your freezer. We're talking about a slushy, super compressed mix of water, ammonia, and methane, all crushed under insane pressure and heat. It's a totally different kind of ice than anything we experience on Earth. Now here's where it gets interesting. Both of these planets have thick atmospheres loaded with methane gas. Methane is basically what gives Neptune and Uranus their beautiful blue color, that gorgeous ocean blue you see in pictures. But methane is also the secret ingredient for this whole diamond rain situation. Methane is made up of carbon and hydrogen atoms bonded together, and under normal circumstances on a normal planet like ours, that's just gas. It stays gas. But Neptune and Uranus are not normal planets. As you go deeper into their atmospheres, the pressure and the temperature both skyrocket to levels that are honestly hard to even imagine. We're talking about pressures millions of times greater than what we feel here on Earth's surface, and temperatures that can reach several thousand degrees. So imagine sinking down into this planet, and the deeper you go, the more brutal the conditions get. Under those extreme conditions, something wild happens to that methane gas. The immense pressure literally rips apart the molecular bonds. The hydrogen atoms get separated from the carbon atoms, and once that carbon is free, it starts finding other carbon atoms and clumping together. And here's the thing about carbon. When you squeeze it hard enough, under enough pressure and heat, it doesn't just clump into random junk. It organizes itself into a very specific, very tight crystal structure. That structure is called diamond. Yeah, diamond. The same stuff sitting in engagement rings and fancy watches here on Earth is being created naturally deep inside these ice giant planets, just from crushing methane gas hard enough. So basically what's happening is this. High up in the atmosphere, you've got clouds of methane gas. As you descend deeper into the planet, the pressure builds and builds. At a certain depth, the conditions become so extreme that soot particles, basically carbon that's been stripped of its hydrogen, start compressing into diamond crystals. And once these diamond chunks form, gravity takes over. They're denser than the surrounding material, so they start sinking, falling downward through the planet's interior, like rain falling through our sky, except this rain is made of solid diamond and it's falling through liquid slush and gas instead of air. This is genuinely called diamond rain by scientists. That's the actual term they use. It's not just a catchy phrase for a video title. It's literally what researchers call this phenomenon in their papers. Now you might be wondering, how do we even know this is happening? Nobody's ever sent a probe down into Neptune's atmosphere to check. We can't survive those pressures with any equipment we currently have. So how are scientists so confident about diamond rain? Well, this is where things get really clever. Scientists actually recreate these extreme conditions right here on Earth, in laboratories, using some seriously wild technology. One of the key tools they use is something called a diamond anvil cell, which is basically two tiny diamonds squeezing a sample between them with insane force. Diamonds are used because they're the hardest natural material we know of, so they can withstand pressures that would crush almost anything else. But for studying Neptune and Uranus specifically, scientists have gone even further. They've used massive laser facilities, like the ones at Lawrence Livermore National Laboratory in California, to blast tiny samples of material with incredibly powerful, ultra-short laser pulses. These lasers create shock waves that compress a sample for just a few nanoseconds. But during that tiny fraction of time, the pressure and temperature inside that sample mimic the conditions found deep inside Neptune's interior. It's honestly one of the coolest experiments in modern physics. In one particularly famous experiment, scientists took a material called polystyrene, which is basically a stand-in for the hydrocarbons found in Neptune's atmosphere, and blasted it with these laser shock waves. And guess what happened? Tiny diamonds formed. Right there in the lab, in real time, scientists watched carbon transform into diamond structures under Neptune-like pressure. They used X-ray pulses to actually capture this transformation happening, almost like taking a photograph of the diamonds being born in that instant. It was groundbreaking stuff. This wasn't just theory anymore. This was direct experimental proof that diamond formation really can happen under these conditions. So once we know the physics checks out here on Earth, scientists combine that with computer models of what Neptune and Uranus actually look like on the inside. These models take into account the composition of the planets, the pressure gradients as you go deeper, the temperature at different layers, and they basically map out where in the planet the conditions would be just right for diamonds to form. And the conclusion from multiple studies is pretty consistent. Somewhere between several thousand kilometers below the visible cloud tops, deep in that mushy, slushy mantle layer, conditions become perfect for diamond rain. Now let's talk about just how much diamond we might be talking about here, because this is where things get almost unbelievable. Some estimates suggest that inside Neptune, tons of diamonds could be forming and raining down every single year. We're not talking about a handful of tiny stones. We're talking about a genuinely massive, continuous process that's probably been happening for billions of years since these planets formed. One estimate that gets cited a lot suggests that Neptune could be producing around 10,000 tons of diamonds annually. Just let that sink in for a second. 10,000 tons of diamonds every year on one planet. If you tried to imagine that in terms of value here on Earth, using Earth market diamond prices, it would be worth an absolutely staggering amount of money. We're talking about numbers so large they don't even feel real anymore. Potentially trillions upon trillions of dollars worth of diamond material, if you could somehow mine it and bring it back. Of course, this comparison is a little silly if you think about it practically, because diamonds are valuable on Earth partly because they're rare and hard to get to. If Neptune is producing tons of them every year, and there's essentially an endless supply raining down constantly, then economically speaking, the value would probably crash instantly if we ever found a way to access it. Supply and demand, right? Flood the market with a resource, and suddenly it's not so special anymore. But that's kind of a fun thought experiment anyway. Just imagining a world where diamonds are as common as raindrops really puts into perspective how here on Earth our sense of value is shaped by scarcity, not necessarily by how amazing or rare something actually is in the universe. Now here's another mind-blowing detail. Some scientists believe that these diamonds don't just fall and stay as diamonds forever. As they continue sinking deeper and deeper into Neptune's interior, they eventually reach a core region where things get even more extreme. In this deep, hot, and incredibly pressurized zone, some researchers think these diamond chunks might actually melt. Yeah, diamonds melting. Under normal Earth conditions, diamonds don't melt. They need insanely high temperatures combined with the right pressure. But deep inside Neptune, those exact conditions might exist. And if diamonds do melt down there, they could form something even weirder. A liquid diamond ocean. Picture that for a second. An entire ocean, made of liquid diamond sloshing around near the planet's core. That is genuinely one of the most bizarre and awesome images in all of planetary science. Some scientists have even speculated that solid diamond chunks, sort of like diamond icebergs, could float on top of this liquid diamond ocean, similar to how ice floats on water here on Earth. Just imagine that scene. A shimmering black ocean of molten diamond, with solid diamond chunks drifting across the surface like icebergs in some alien sea. This whole idea isn't confirmed 100%, since again, nobody has actually traveled to the core of Neptune to check. But based on the physics and the experiments done in labs, it's considered a very plausible explanation for what's really happening deep inside these planets. Now, why does this matter beyond just being a wild fun fact? Well, understanding what's happening inside Neptune and Uranus actually helps scientists piece together bigger puzzles about how planets form and evolve throughout the universe. Ice giants like Neptune and Uranus are actually incredibly common types of planets when you look at other star systems beyond our own. Many of the exoplanets discovered so far, thousands of them at this point, seem to fall into this ice giant category, sometimes called mini-Neptunes. So by studying diamond rain and the internal structure of Neptune and Uranus, scientists aren't just satisfying curiosity about our own solar system. They're building a better understanding of a planet type that might be one of the most common kinds of worlds across the entire galaxy. This connects to bigger questions too, like where elements go as planets form, how atmospheres evolve over billions of years, and even how magnetic fields get generated on these strange worlds. Interestingly, Neptune and Uranus have some of the weirdest, most tilted, most off-center magnetic fields of any planets we've studied, and some scientists think that liquid diamond ocean or similar exotic layers inside these planets might play a role in generating those strange magnetic fields. It's honestly incredible how one weird phenomenon, diamond rain, connects to so many bigger scientific questions about planetary formation, magnetism, and the overall structure of worlds that are completely different from our own. Now let's zoom out a little and think about the sheer scale of this. Neptune is about 17 times the mass of Earth. It's absolutely massive compared to our home planet. And a huge chunk of its interior, that mushy icy mantle layer, is under conditions extreme enough to create diamonds constantly. So when we say diamond rain, we're not talking about some tiny localized event happening in one small corner of the planet. This is potentially happening across a massive portion of Neptune's interior, all the time, non-stop, for the entire multi-billion-year history of the planet. Think about how long that's been going on. Neptune formed around 4.5 billion years ago alongside the rest of our solar system. If diamond rain has genuinely been occurring since shortly after the planet formed, that means this process has been happening continuously for an almost unimaginable stretch of time. Billions of years of diamonds forming and sinking down toward the core. Billions of years of that potential liquid diamond ocean building up, layer after layer, deep beneath the surface. It's a genuinely awe-inspiring thought when you really let